Now, let's try to look at what if our data has more of categorical responses rather than scale based or rather than quantitative kind of data. If I have more categorical, and if I want to do some kind of analysis across various categories, right? If I want to do it across various groups of scale data, probably I can do some kind of bifurcation based on the data, or probably I can take the help of separate scatter plots, right? So depending on what is my variable, whereas here I am talking more in terms of my output variable being a categorical variable. So let's say I want to talk about the default on a particular default on loans. Yes or no kind of response would be there. I want to try to understand the patterns of yeses versus the no's. Or probably I want to look at, right, any decision which is a good versus bad. I want to know the characteristics of good versus the characteristics of bad. Now, this is where I'm talking about the response which I'm looking at being a categorical variable rather than a quantitative or a scale variable. See, for that kind of a data, I can't use scatter plots, correlation, because all of them, they become more and more appropriate when I'm using with quantitative or a scale data. But for a categorical data, all these tools will become more or less redundant and they don't give me any kind of important conclusion. And today, there are so many applications where categorical outcomes are very much possible, especially with respect to the choices that are typically made by the consumers. And based on the evaluation of the choices, if my decision is lying, then again, the categorical outcomes become, an understanding of the categorical outcomes becomes more and more important. Now, from that perspective, let's say I want to look at one data set. Okay, this is a very simple data set which talks about a consumer to consumer lending market, right? So there are some loans that are being given. These are the statuses of the loans. Now, here we are talking about almost 5,600 odd records, wherein in the status, the current, when we are saying current, it is active. There are a few more things in this called late, means there is a delay in the payment, and there is a status called default, which is telling me that the people have defaulted on this particular loan. So the current status is that the credit grade of the borrower, probably anything with multiple A's is a very high grade, but B, C, it's going down, and HR is representing the high risk, which is the worst in the grading. Probably we have a B, we have a D, we have a E. Below that E lies this HR, which is called as high risk, and we also have a category called NC, which is not no, which is like a no rating, right? No credit grade that is assigned. It is more like an unrated. So just for an understanding purpose. And this is the loan amount that has been taken, and this is the age of the loan, and whosoever was the borrower, the interest rate that was applicable for the borrower, I can put it even in a percentage form. Probably the interest rate is this borrower has paid 15%, this borrower has paid 26.5% because there is a high risk associated, something like that. And the debt to income ratio for the borrowers, okay, 4%, 2%, some such kind of a debt to income ratio existing for each of these borrowers. Now, I really want to see the characteristics of the current versus the late versus the default borrowers, right? So that is where I am getting into the categorical data. I want to analyze the current versus the default versus the late. Is the amount playing any kind of role on the status, age playing any kind of a role, borrower rate playing any kind of a role, or debt to income ratio playing any kind of a role? So for that, I am more and more interested in coming out with what we call as variable wise, single variable wise. I'll try to analyze amount across these three groups, age across these three groups, and for that we come out with a slightly improvised version of a histogram, which we are actually calling as the density plot. I'll talk about this density plot in a while from now, but a slightly improvised version of a histogram which can help us doing the comparisons more and more effectively. So our major intention is to distinguish between the good loans and the bad loans. So what kind of loan really plays an important role in the default? Which kind of loans typically are paid on time? Now that will help the lender determine which loans will result in timely payments and which of them can really result in default. Is there any kind of a pattern? Is there any kind of an information that can traditionally help in terms of this analysis? That too, without using too much of statistical tools and patterns, just by looking at the graphs, I would like to make out this kind of stuff. Now here it's more like linking the categorical variable called status. I cannot use scatter plots, I cannot use correlations here. So on one side I'm relying more and more on status. Right? I'm relying more and more on the status here. Now, so here what we try to do is we try to come out with a distribution of the input variable. So how the amount has been across all these three statuses. How the age has been across all the three statuses. How the borrower rate has been across all the three. I'm not looking at a single summary like a mean or something. I'm looking at the entire distribution of values across all the three states. So I would like to see if the distribution of the loan amount differs between the loans that are current and late and default. So if there is a clear difference that comes out, it's a very important thing that I can make a conclusion. Size of the loan does make a difference. So probably take care, depending on the loan amount that is being asked for, I can very well assess whether it is going to be into default or whether it can be made into a timely payment. Similarly, so here I could look at the quantitative elements. Probably I can look at the distribution of amount with the status, age with the status, borrower rate with the status, debt to income ratio with the status. Now those kind of things where one quantitative element is being looked at across multiple categorical elements, we try to come out with the density plots for them. So more or less like histograms, but where the interval is very small. The interval of the histogram is very small, so that it looks more and more continuous data. So the distribution is plotted in the most granular form, wherein I can look at if amount is playing any role on the status, age is playing any role on the status. Now for that, there are multiple ways of doing it, but what I can very well do is, we will try out one by one. Okay, let's try out for the amount, right? So for the amount, what I will do is I can go with a minimum value. I will find out the minimum value and the maximum value first of all. right? So, or probably the best thing is come out with a pivot table. Okay, for this data, I am inserting a pivot table. But yes, if I go with, okay, yeah, rather than going with a pivot table here, all right, we can go with a pivot table also. We will insert a pivot table for this whole data, right? And here, first we'll try to do it with the amount. So I'll try to drag the amount out here. These are the different possible amounts. And I'll also drag the status here so that I want to look at it across the different statuses. So, and I will drag again the amount here itself so that I get a counting. Okay, 1000 is the amount. These are the stuff. Now, what I would like to do is, instead of keeping the amounts like this, I would like to group these amounts. I would like to group it. Okay, the minimum value is 100, maximum value is 25,000. So I'll try to group it with very minute intervals. So probably let me try to do the grouping with 500 being the group size. Okay, so these are the different intervals that we have got. 716, 306. I really don't want the blanks, so I'll remove the blanks for my data. Here also, I really don't need the blanks, so let me remove the blanks from here as well. So these are the intervals, right? And what I can very well think of doing is, all these I will actually try converting them in terms of the percentage. I want a separate percentage for the column values, percentage of the columns. So what I'll do is count amounts instead of keeping them as it is, I'll say show the value as percentage of the column totals. So which means 100 to 1400, I see 13%, and finally all these work out to this much. Now what I can very well do is, with this data set, I will simply go with a line chart. Right, probably from here I will start with this data set. I will go with a line chart. Now what I could clearly see is these are the patterns. Now you could see this is the traditional pattern that is coming up. Probably the graph is looking more or less similar across, except for the fact that somewhere here the default is having more amount. Probably if you look at the current, so the current amount is somewhere I mean around 3000. We are seeing around 5%, whereas in case of default a huge amount is being issued out here. Apart from that, what I mean, we don't clearly see any kind of a big shift in the pattern in the graph when we are looking at with respect to the default, or probably the amount in different intervals is hardly making any kind of a difference. There is no significant way to say that very high amounts borrowed are resulting in a default, because we hardly are able to see any such kind of a pattern which could really differentiate. Right here we are seeing we are 10,000, probably the current amount is much higher, probably at 15,000 slightly. The default is much higher. So we are not able to come out with a distinctive pattern on the amount at the amount which is where which has a possibility of a default, because even till the last we are seeing all the three colored lines coming up. So this is not giving me. So this is what I actually call as the density plot. I'm trying to look at the density in a very minute interval of time. It's as good as I'm coming out with a continuous kind of a graph. Now the same logic probably we can try out with respect to the age, wherein again I'm looking at a pivot table for this entire data, wherein I'm coming out with the age. I'm getting different ages here. The same logic I'm counting here. I'm doing it across the different credit statuses, right? I can do it across the different credit statuses, and the same logic again. I'll do the grouping, right? I can do the grouping. Probably I'll keep it as it is itself. This grouping is good enough. Whereas instead of relieving them in this format, I can show them as a percentage of the column totals. And traditionally, I don't need blanks, so I'm removing the blank from my data. Now, probably I should try doing a plotting of this on insert line chart. Now, here I am able to see a very interesting pattern. There is a lot of shifting towards the right for the default, right? So whether it is the average age or whatever. Now you could see in the current case, there are majority of the loans which are very young. There are almost 15 to 20% of the loans which are much below 1 year. Whereas probably in the late payment category, we are seeing a slightly different numbers. Whereas in case of default, which is shown by this red, they are all occurring at a very later age, which means probably no one really wants to default in the initial stages itself. As the loan progresses, we might experience some kind of defaults occurring, which is what is clearly coming out. So we really don't need to bother about the default in the initial years, but if the payments don't occur at later points in time, there is a good chance to believe. So which means the time period of the loan, if it is for a shorter period, probably the chance of default is much lesser compared to the loan being given for a longer time period. One simple analysis that can come out from here. However, I can very well analyze that the amount that is being borrowed is really not having any kind of an influence. But at the same time, now I would like to see whether the borrower rate, the interest rate is, is it like higher interest rate means there is a possibility of a default? Is there any such kind of a pattern that is coming up? I would like to evaluate even that. So for that, I have brought in the borrower rate, doing the counting of the borrower rate across the various statuses. And now what I would also try doing is just like the way we have done earlier. Probably I would like to go here on a very limited kind of a gap. So I'll go with 0.025 as the gap. So these many records are there, and this records also I will try to establish them as a percentage of the column total, and definitely I don't need any kind of blanks in my data. So overall I will end up doing a line chart with these elements. Now this graph, if I traditionally see, the peaking, or probably if you look at the borrower rates towards the end, I'm seeing only the red one and the green one. The blue one probably looks like it has ended up here itself. So there is a possibility that higher is the interest rate, and probably even if you look at in the initial stages, the peak is dominated by the blue. Up to this stage, up to around 20 to 25%, 20 to 22%, the peak is dominated by the blue. Means majority of the loans are current loans. But at a later point, I am seeing the default and the late payments are dominating after that. Right here, the default is dominating in this zone. Again, for some period, the late is dominating. Again, the default is dominating in this entire zone, which means there is a good chance for me to make a conclusion that higher is the borrowing rate, higher is the possibility of late payments and default, and very high the interest rate. Probably it is coming out as a possibility that very high could be the default that can happen. So these are the graphs which are more or less showing the distribution of the data across all kinds of borrowing rates, so that I can make a conclusion towards which side the whole pattern of the graph is tilted. So with respect to the borrowing rates, I have a conclusion to make. And finally, I can also look at debt to loan ratio. Should I really need to evaluate the debt to loan ratio as well while giving a loan? Right? If it requires, yes, I have to evaluate how much loan can be given by looking at the debt to low income ratio itself. Sorry, debt to income ratio. I have to really evaluate that. Okay, on this pivot table, I have taken the debt to income ratio here. I am counting the debt to income ratio across all the categories. Obviously, I don't need blanks in the category. And here, I would also like to do the grouping just like the way we have done for the others, wherein I would like to group the selection. Okay, here the debt to income ratio is going so high here. So probably I would like to look at a gap of 1000 across. Okay, this is the gap of 1000 that is coming up across, or probably I am not that much interested in the other bigger one. So probably I would like to look at with a gap of 100 itself. It hardly matters, or even that is looking much on the higher side. Let me see. Across the numbers are much lesser itself, 11%, 18%. Okay, probably there are a very few towards the end which are very much on the higher side, right? These are the numbers which are very much on the higher side, and that is what is making our analysis more and more biased. That's okay. Then what we can do is we will very well go with the option of of 1000 itself, right? And now what I can very well do is or probably if I go with 100, what is the scenario? Okay, even if we go with 100, we don't have any beyond this group. So probably let me try out 10 instead of 100 again. Probably let me try 0.1. Yeah, now I think we get a fairly decent kind of a distribution. So I'll try to go with a value setting where I would showcase it as a percentage of the column total, and obviously I would like to do a plotting for this to understand the pattern much more effectively, wherein if I'm looking at, probably I could clearly see if I ignore these parts. So see, debt to income ratio more or less looking the same, right? At some point the debt to income ratio is much higher, so probably let's say in this range. See, after a certain range, after 60%, 70% kind of stuff, almost everything is flat. Either I remove that extraordinary values which are very much outliers and I check them out again to understand a general pattern, but otherwise up to this point I could not come out with a clear differentiator in terms of the debt to income ratio. So which is where we can simply ignore it, because there are a few outliers that are present in the data. So this is the way we can very well bring out the various density plots, histograms in a much more granular kind of a form, which can really help us to visualize the pattern in the data across the multiple categorical subcategories. Similarly, if I want to look at the subcategory now, if I want to look at a categorical data, just like in our data case, probably if I want to see the credit grade across the different statuses, just like the way I have seen. So which credit grade will result into more of a default? If I am more and more interested in that kind of an aspect, again I can look at the same across these various. I can bring in the credit grade on one side, the status on the other side, and probably I can do the counting. And again the same, this counting also I can put it as a percentage of the column total, wherein I can ignore the blank from my data. Now across the various, these are the numbers that are traditionally coming out. So what I could very well see is A, double A. Now probably I can very well get into, okay, for A these are the numbers. For B these are the numbers. Now what I could clearly see is I can express them as a percentage of the row totals rather than the column totals, because okay, one way I can see is across each category. Okay, let me do a two-dimensional kind of a picturing. I'll go with a line chart. Okay, I could see here in the initial rating stages A to probably up to D, the domination is by the blue line, which is the current. So the lower grades typically are having the current kind of a scenario itself, whereas the ones which are having the high risk, they are, majority of them are falling under the default category, right? The high risky ones are coming majorly into the default category here. Or probably I can do the same analysis using this kind of a chart as well. Now you could see in the A grade, 60% of them, right? Under the A grade, 60% of them are the current, around 15 to 20% are under the default, and another 20% of them are under the late category. Similarly, if I'm looking at the double A kind of a grade, the same logic is coming up. Now, if I do the same exhibit, and probably if I'm looking at high risk kind of a category, I could see very few of them are current. A big proportion of them are under the default category, and very few of them are under the delay. Probably either I can keep it as it is, or the best way is, let me try expressing it not as a percentage of column total, let me do it as a percentage of the row total. This will give a much better picture, because within the A category 97.4% of them are current. Only 0.47% of them have defaulted, and 2.2% of them are late. Whereas when I come to this high risk category, only around 84% of them are current, 11% of them are late, and 3.37% of them are coming under the default category. And similarly, the same thing goes with not credit, no credit rating being awarded. I could see that this is the case. So which means this kind of a graph, one which splits across the multiple subcategories, looking at the multiple subcategories across the different categories set and trying to identify the distribution across the categories, is what is comfortable going with this kind of a chart, which is actually called as a spine plot. Now in spine plot, actually two things come up, right? One, as we have seen, okay, for A, I am getting a kind of a stacked column chart like this, right? Probably for high risk, the stacked column chart is giving something like this, right? But at the same time, in this graph, what also comes out, this is a normal stacked column. But if this stacked column is packaged by the width of this, right, the width of this representing the total number of records, here we are having all of them to be of equal width. But if we have the width of this matching with the total number of records of A, how many records of A are there? How many data points? So what proportion of the loans have A category? So probably it's like, right, if I am doing one more scenario here, wherein I am trying to do the count if within this, I am trying to count this A category, right? I am trying to do the counting of the A category, wherein I am trying to find the count of this entire set. I am trying to see, okay, A based loans are around 7% of them. And similarly, when I go ahead, so overall, I have 7% of the loans which are A rated, 8% of them which are double A rated, and around 21% of the loans which are high risk, 20% of them which are E rated. Now, if the graph is plotted taking into consideration even this, so when I am saying E rated is 20, the width of this should be equal to 20 units. Whereas the width of probably this one, the not credit rated, should be very, very narrow, 1%. When I combine those two things, direct plot in Excel is not possible. Some statistical tools will generate that. Probably here we may have to look at it as a two individual kind of plots, one exclusively targeting. So it's like this. For this, I can have one more plot, probably like a column chart. I can have a different column chart altogether. right? Not that. Probably let me try. So if I am actually looking at a simple column chart between these two, okay, I may have to look at a simple column chart between these two. Okay, let me try out, change the data. Okay, here I will have, let's say, these values on the X, on the Y, and here I will have these values on the X. So here I could clearly see the proportions across. So it's basically I may have to combine these two graphs. But in a typical spine plot, what happens is depending on the size of this graph, the width of this graph is going to come out. Of course, we can think of some artificial way or using some kind of macro. We can try to combine these two. But a real spine plot, if you are trying to use some kind of statistical softwares like R, you can very well generate this kind of spine plot. So spine plot is visualizing the cross tabulations of the data, especially in case loan status versus the credit grade. Across the different credit grades, what are the loan statuses? What percentage of the loans are current? What percentage of the loans are defaulted and all? And the width of the bar should correspond to the number of loans with a particular grade. So that is not captured here. Here in the regular plot, we see that the width is more or less uniform across all the grades. So just to summarize the stuff, whenever I am using a categorical outcome data and I want to really do the analysis across the different categorical outcomes, the behavior of the different input variables, I can either resort to density plots or the spine plots. For each of the categories, if I am looking at the distribution of the quantitative data, we are referring to density plots. For each of the categories, if I am referring to the categorical data, categorical input variables, I am referring to spine plots. They are very powerful tools for investigating the data where my response is more categorical in nature. So all that is done is it is splitting up the different input variables across the different layers of the target variable. And fine granularity is coming out in a density plot, which is a much more improvisation over the traditional histogram. And we see today this kind of analysis is very much important because these kind of responses occur very frequently in a lot of business applications, marketing, where we are looking more and more into the consumer's choices, preferences. Decision making has to happen by understanding various categorical variables, right?